So good afternoon again, and we will start with our last session. And in a way, we continue from where Professor Aru stopped, the same discussion about the effect of AI on humans. And we have an outstanding scholar, a researcher from Tallinn University, Oliver Laas, who is a well-known philosopher in Estonia and quite often taking public floor on the topic of AI effect on society and human condition. So please, Mr. Laas.
All right, thank you everyone for coming here and listen to me ramble for 30 minutes. The title of this talk, as you can see, is The Age of Moralizing Machines. And the reason I mention this is because the title is a play on the titles of two optimistic books by futurist Ray Kurzweil, The Age of Intelligent Machines from 1990 and The Age of Spiritual Machines from 1999. The behavior of AI systems is governed by technical norms, and these can facilitate technology paternalism by limiting user freedom for their own good. Since technical norms control user behavior in accordance with legal and moral requirements, it's pertinent to ask whose norms are embodied in AI technologies and what are the costs of automating legal and moral decisions. And I will argue that the extent that moral and legal requirements are codified in technical norms, this can hamper the creation of free speech that could spur legal, moral, and societal change by initiating normative disputes, both in society at large as well as in our court systems. My goal is to highlight what we may lose by automating normative decision-making and limiting user freedom. I'll begin with a few remarks on terminology and a couple of assumptions I'll be making, theoretical assumptions, because these will both help explain what I mean by things like technical or technology paternalism, and will hopefully support the case I'll be making. So first of all, what do we mean by AI? Let's go over these things very briefly. By AI, I'll mean an artificial agent that can behave intelligently in some domain. What do we mean by intelligence in this case? Well, basically, by intelligence, we mean the ability to effectively optimize in a given domain based on the optimizer's preferences. So here's an example of an optimization problem. It's the old classical textbook case of the so-called secretary problem. So suppose you want to hire a secretary. How many candidates should you interview in order to find the best person for the job, given that you can't return to the candidates you've already rejected? That's an optimization problem. It's an optimal stopping problem. When should you stop interviewing and hire the next person to get the best one for the job? And I mean, those of you who are young enough to still think that dating is a good idea, then that's also an optimal stopping problem. When should you stop dating and settle down to get the best partner, right? So that's what we mean by optimization problems. What do we mean by effective solutions to optimization problems? So usually in the AI literature, what researchers mean are speed. What they mainly mean by effectiveness is speed. How quickly an agent can solve optimization problems. I suspect that the emphasis on speed comes from IQ tests, where we also measure the results not in terms only of correct answers, but also in terms of how quickly test takers can arrive at those answers. Now, when we're talking about generative AI, which I'll be talking about, we mainly mean AI applications that use a specific technique, that is machine learning, which is a set of computational methods for independently learning information from large sets of training data. And generative AI can generate new output based on patterns learned from training data in response to user prompts. So you're all familiar with these applications, ChatGPT, Midjourney, et cetera, et cetera. Now, the theoretical background here that I'll be assuming is value-sensitive design. It's a theoretically grounded approach to the design of technology that accounts for human values in a principled and comprehensive manner throughout the design process. And this research program goes back to the early 1990s when researchers showed that software can contain the assumptions and values of its designers. So a classical example, by now classical, that I'm again assuming all of you are familiar with, I'm guessing there's no one in here who has never heard of or used YouTube, for example, right? Well, YouTube has recommendation algorithms. It recommends other videos based on what you've already watched. And those recommendation algorithms use machine learning by comparing your viewing history to that of other similar users in order to come up with new recommendations. Well, the values or value assumptions codified in those algorithms are not actually designed to give you, the viewer, specifically what you might want to watch. Yes, they're trying to do that too, but the main goal is to try and keep you on the platform as long as possible, to keep you watching as long as possible. Why? Well, in order to show you more ads, because the more ads you watch, the more revenue Google gets out of it. So it's not a neutral algorithm. And studies have shown that as a result of this sort of value proposition or assumption in those algorithms, the YouTube recommendation algorithm tends to, sooner or later, start recommending more extreme, more polarizing content. Why? Well, because, as Jan Aru previously discussed and illustrated some of the more primitive or evolutionarily sort of hereditary aspects of human cognition, as human users, we tend to react more strongly to emotionally charged content, especially the kinds of content that elicits negative emotions. And of course, the algorithm learns from that. You click more on those videos. You spend more time watching them and sharing them. Now, because the notion of value is seldom explicitly defined in value-sensitive design, I'll adopt the following simple definition for the remainder of this discussion. I'll say that a value is what a person or group of people consider important in life, and which is both of moral import as well as implicated in systems design. Now, value-sensitive design takes an interactional stance by claiming that the influence of a technology on humans depends on its design, its features, context of use, and the interests of stakeholders. The impact of a technology on users is not completely determined by design. Rather, values are implicated through users' engagement with a technology. Now, one implication of this stance is that the design space of any given artifact involves both the technical as well as the corresponding socio-cultural design space. In other words, a technology is never designed in isolation from the cultural and social context and the legal context in which it is developed and utilized. Now, technology is colloquially understood as referring to individual machines and tools. So if I say technology, you might think something like, well, this thing here, this remote control, or your smartphone. But I'd like to argue it's actually more fruitful to interpret this term as referring to socio-technical systems. Why? Because it highlights the relationships between entities that may otherwise be overlooked when focusing on just individual devices. Now, this term has been defined in various ways, but I prefer to think of socio-technical systems as systems that are constituted by three things: technological artifacts, human agents, and institutions or rules followed by these agents. So artifacts are indeed those discrete things, your smartphone, this remote control here, etc. These artifacts have a dual nature because their technical function is grounded in both what they're physically like, but also in the intentions of designers and users. Institutions and rules embody social norms that prescribe how agents ought to act. So let's take the smartphone as an illustration. Again, usually as an end user for you, it's just a big screen that you buy every couple of years, and you use it to access whatever content you like. But this actually obscures the fact that there's an entire system, an entire infrastructure that's responsible not only for creating your smartphone, but maintaining it, starting with cell phone towers, ending with hardware manufacturers, software developers that are pushing updates, etc. There's a whole host of people and stakeholders involved in making sure that your smartphone keeps working. And these stakeholders have conflicting interests. They're not all aligned. They're not all on the same page with regards to what they want a technology to do and what their values are. Now, AI systems are a subset of social technical systems. What's the difference? Well, human agents in such systems are supplemented or supplanted by artificial agents that exhibit autonomy and interactivity. And institutions are supplemented or supplanted by technical norms, understood as causal physical rules that guide the behavior of artificial agents. And these norms can be embodied in the software that constitutes a given agent or in the design of the AI system of which it is a part. Remember the YouTube algorithm that I described earlier? That's an example of a technical norm, actually, that governs the workings of a platform like YouTube. And the interesting thing about technical norms is that they can codify epistemic, legal, and moral norms into technologies by guiding their design in ways that steer users toward legally and morally desirable behaviors or constrain their ability to behave in legally and morally undesirable ways. The conceptual foundations of this approach were laid by Lawrence Lessig in his 2006 book, Code is Law. He argued that architectures, including software architectures, can be used to control user behavior in accordance with, say, legal or moral requirements by limiting what they can or cannot do with a given application. So I'll give you an example or try to illustrate the notion of AI system in case that's somewhat abstract or theoretical. I'm guessing all of you have read or heard of deepfakes, right? So these are synthetic media, images or videos, where a person is depicted as saying or doing things that they've never said and done. And that media is usually generated using machine learning tools. Well, that is an example of an AI system. Because sure, we have people who are actually creating those deepfakes, but the output of those machine learning models is somewhat autonomous and independent of what the user intends. They have to try and fiddle with the system to get the output that they want. So we have an artificial agent in the game as well. And furthermore, there are technical norms in this entire system which guide what the user can and can't get out of the system. So another example, does anyone here have the latest and greatest Google Pixel Pro 9 phone? If you don't, that's not a pitch. I'm not sponsored by them. The reason I mention this is simply because in the Google Photos app, you can now insert people into photos that were never on the photos to begin with. So basically, the new hardware and software combination that you have in the new Pixel phone allows you to generate, well, quote-unquote, deepfakes with just a few taps on a screen. Of course, Google tries to limit it through technical norms so that you can't create anything illegal using their software, but it is, nonetheless, a kind of AI system that has all the components that I just mentioned. So what do we mean by technology paternalism? Etymologically, paternalism, as everyone here knows, comes from the Latin pater, meaning father, and designates actions that limit someone's autonomy and freedom for their own good. And whether an action is paternalistic or not depends both on its outcome as well as how it's perceived. So we can say that one party performs an action that affects another party, and that action is paternalistic if it is perceived by the second party as limiting their freedom, is perceived by the second party as being non-defeasible, and the first party who's performing that action claims that it's undertaken in the interest of the second party. And again, the point here isn't that paternalism is bad per se. You go to your doctor for a prescription, they tell you what you have to do to get better. That's a kind of a paternalistic action. But the point here that I'll get to in a minute is that when your doctor behaves paternalistically toward you, you can resist that. You can refuse to follow their treatment plan, at your own peril, of course, but you can do that. With technology paternalism, you really can't unless you hack the software that you're using. But technology and its operations can appear paternalistic. Here's a familiar classical example from Bruno Latour, and I quote, "Early this morning, I was in a bad mood and decided to break the law and start my car without buckling my seatbelt. My car usually does not want to start before I buckle the belt. It first flashes a red light, fasten your seatbelt, then an alarm sounds. It's so high-pitched, so relentless, so repetitive that I cannot stand it. After 10 seconds, I swear and put on the belt. This time, I stood the alarm for 20 seconds and then gave in. My mood had worsened quite a bit, but I was at peace with the law, at least with that law. I wished to break it, but could not. Where is the morality? In me, a human driver, dominated by the mindless power of an artifact? Or in the artifact, forcing me, a mindless human, to obey the law that I freely accepted when I got my driver's license? End of quote. So by designing cars in this way, we delegate the work of ensuring that drivers and passengers adhere to the legal and moral imperatives of safety to technology. As a result, the relevant mechanisms are laden with technical norms. And I don't drive personally, but those of you who do and have relatively modern cars probably recognize this example. Your car will likely also loudly complain if you don't follow the norms, rules, and regulations that you're supposed to follow. Now, Speakerman and Palace, in their 2006 article, define technology paternalism as follows. If a technology controlled or designed by one party performs an action that affects another party directly, then that action is an instance of technology paternalism if, again, it is perceived by the second party as limiting their freedom. If that action cannot be defeated without affecting the functionality of the technology, the designer claims that this action is in the interest of the user, and the technology performs that action autonomously. And the same authors note that this definition highlights two ways in which technology paternalism differs from the familiar human version. The relevant action, in this case, is performed by an autonomous artificial agent instead of a natural human agent. So, again, if your doctor gives you a recommendation about what you should do to get better, you can dispute them. You can debate with them. You can get a second opinion. If your car says it won't start unless you buckle the belt, well, you can argue with the car, but you'll just look like a crazy person. It won't start until you hack the machine or put on the belt. Secondly, while human paternalism requires obedience, which could be resisted in principle, technology paternalism involves complete obedience. If an AI system has been designed not to perform certain tasks, then users can defeat such limitations only by hacking the system or opting for more permissive technological alternatives. As Lessig notes, code is law in this case. And technology paternalism is a matter of degree. At one extreme, we would have, say, a car that doesn't start unless all passengers have fastened their belts. And at the other end, we have old-school cars that don't care whether passengers have their belts on or not. And whether some degree of technology paternalism is desirable is a question that I'll return to later in this presentation. Now, prompts in ChatGPT, Midjourney, and many other popular generative AI applications are generally filtered. This is how the owners of these applications try to limit users' ability to generate morally or legally problematic content. So, for example, ChatGPT refuses to provide instructions for criminal activities, and Stable Diffusion doesn't respond to prompts for visual content about celebrities or pornography, for example. And filters in generative AI services are instances of technical norms. The contents of these norms are influenced both by extant legal and moral norms, as well as by the judgments of the service owners. They are also influenced by tech companies' concerns for their reputations. For example, Google and Meta limit users' ability to post or find certain kinds of content because its availability would steer advertisers away from their platforms. And similar business concerns probably influence the technical norms that AI companies implement in their own services. Now, filtering can be seen as an instance of technology paternalism. First, it limits user freedom by vetting their inputs and refusing to generate certain kinds of outputs. In other words, users are not free to run these applications for whatever purpose they see fit. This is because most commercial generative AI applications are not free software. Now, what do we mean by free software? I don't mean free as in beer. I mean free as in freedom. So to explain this, let me quote a well-known free software advocate, Richard Stallman. The freedom to run the program means the freedom for any kind of person or organization to use it on any kind of computer system for any kind of overall job and purpose without being required to communicate about it with the developer or any other specific entity. In this freedom, it is the user's purpose that matters, not the developer's purpose. You as a user are free to run the program for your purposes. End of quote. Note, however, that these purposes could in principle be illegal or immoral. But the program does not pass judgment on such matters. That is the job of other people. By automating such judgments, by making them the job of the program, we are increasingly limiting user freedom while also unburdening ourselves from moral deliberation. Second, users cannot easily alter the filtering without affecting the functionality of generative AI applications. This is because most of them are mainly available as services. Now, software as a service involves users renting access to the provider's servers. Software as a service, therefore, is usually made available as a web application, accessible via the browser. Now, this can limit user freedom. It involves sending user data to a server owned by someone else, running software they've set up to do part of the user's computing for them, and returning the result to the user. Users essentially cede control of a part of their computing to the service owner. And as a result, users can't easily check what the service does with their data, nor can they change how the service functions. In the case of generative AI, there are ways around filtering. For example, you could use prompt injection to circumvent the service's limitations. And this involves crafting user input that makes the machine learning model follow the user's instructions instead of the instructions followed by its owners. So it's been patched out by now, but a well-known prompt for ChatGPT was known as Dan, or do anything now. And other prompts are discovered regularly. The trouble here is that this kind of hacking can bypass filtering. It's generally against the terms of service of the companies providing access to their machine learning models. So for all practical purposes, jailbreaking is not really a viable option for the average user. Third, filtering is often justified by claiming that it's good for the users, that it's done for the sake of improving user experience. Actually, of course, filtering is equally motivated by the service owner's desire to avoid litigation and to avoid damage to their reputations. And finally, generative AI applications filter user input autonomously. There's no human somewhere checking what you type into ChatGPT. It's done automatically. Now, all this should show you that generative AI services actually satisfy the definition of technology paternalism that I gave earlier. Now, it follows that user input filtering in generative AI applications is an instance of technology paternalism. But then you might ask, okay, so what? I mean, I'm having fun with this stuff. I'm generating my research papers in half the time that it used to take me, and all students have more free time to party or sleep or whatever because they don't have to write their papers anymore. Well, there are certain costs, I'd like to argue. Many generative AI applications are used as tools in creative endeavors. Creators employing traditional tools, brushes or typewriters, never face situations where they could not tackle certain topics because their tools considered them inappropriate. This is the situation faced by those who use generative AI services for creative endeavors, unless they use prompt injections to jailbreak those services or run their own small models. So figuratively, generative AI applications pass judgment on the user's request before deciding whether to fulfill it. And this, I'd argue, is a qualitative change, since such technological moralizing didn't exist in earlier tools. As AI is increasingly embedded into our devices and applications, it'll be harder and harder to escape such moralizing technologies going forward. On the one hand, automating content moderation in this way would limit harm and cut costs. On the other, it can contribute to solidifying the current normative status quo in society by hampering the creation of forms of speech that could spur legal and moral change. Consider a work like Henry Miller's Tropic of Cancer, which was the subject of obscenity trials upon its publication in the US in the 1960s. The Supreme Court decision in 1964 that the book was not, in fact, obscene had an impact on societal norms regarding free speech in literature. Miller wrote his novel using traditional, non-moralizing technologies, pen, paper, typewriter. As a result, he could write whatever he wanted while composing his text. Legal and moral judgment was passed after the finished text had been published by other people, not by his tools. Suppose a modern-day or near-future author would want to compose a similarly controversial work. If generative AI services are embedded in their tools and devices, then their efforts could be hampered, if not outright thwarted, by paternalistic technology. And as a result, society could be deprived of the opportunity to address the issues raised by their work through legislation or collective moral deliberation. Now, technology paternalism, as enacted through the technical norms of generative AI applications, raises a number of interesting issues, I think, and I'd like to address some of them without proposing specific answers. Now, first of all, one could respond that the issue I raised is a pseudo-problem because users can just not use AI tools. And this is true, but AI is increasingly integrated into productivity software like Adobe Suite or Microsoft Office and into operating systems of our devices. In productivity software, automatic user input filtering can be implemented to limit what users can do. In operating systems, AI can be used to detect and classify users' files. For example, Mac OS already does this. And for surveillance under the guise of improving user experience. This is essentially why Microsoft's proposed recall feature was so controversial among cybersecurity experts and privacy activists when it was first announced earlier this year. In a nutshell, it may be increasingly difficult for the average user to find and use software that does not have embedded AI. And even when not used for filtering user input, similar technology could in principle be used for monitoring the legality and morality of user actions on their own devices. For example, the European Commission wants to mandate client-side scanning, using machine learning models to detect potentially illegal content on user devices for all encrypted communication platforms. And this would effectively turn smartphones and other devices into moralizing machines for surveilling whether users are doing anything illegal or immoral. Since governments would be in control of the list of illegal material to be sought for in user devices, the system could in principle be extended to detect any kind of material that those in power deem displeasing at any given time. Another objection is that user could just add whatever controversial content to AI output later. So again, what's the problem? What are you talking about? But this may not be easy in the long run if regular use of AI tools, as Jaan Aru showed, leads to de-skilling among users whose additions may no longer be on par with AI output. There are some early signs that relying too much on AI tools would inhibit skill acquisition. Again, Jaan Aru gave multiple examples, but here's another one. There was an experiment in MIT where students could use either ChatGPT, Meta's CodeLlama, or only Google to solve coding assignments using an old language called Fortran. And afterwards, they had to solve similar assignments without any external help. Well, the ChatGPT group failed in its entirety. The CodeLlama group, well, about half of them passed, and all of the students who could only use Google and had to figure this stuff out on their own, all of them passed when tested. So similarly, users who are accustomed to using AI tools and other kinds of tasks may struggle or be unable to perform same tasks unaided. And if the underlying model is open source, users can simply fork it if they find the filtering in particular applications too restrictive. Alternatively, you can run small models on devices. But again, these things can increase user freedom, but again, they also open the door to nefarious uses. So another point is that as an issue of concern, technology paternalism arises from liberal presuppositions about the value of individual autonomy and freedom. And if you don't share those presuppositions, then you don't really see the problem, I suppose. And also, you probably noted that throughout this talk, I've assumed that deliberation is important for a democracy. If your view of democracy is different, or you don't think that democracy is a good idea at all, then maybe the fact that we'll potentially be constrained in debating the normative status quo in the future is a non-issue for you. Finally, one could argue that generative AI applications need guardrails because they can facilitate the creation of harmful content online. Sacrificing user freedom for collective online and offline safety is an acceptable trade-off in this case. And perhaps it is. But we shouldn't neglect the qualitative change in our technology that this entails, nor should we diminish or be dismissive of what we may have to give up in the process of trying to implement these technologies safely. And that's it. Thank you.